Namaste, myself Shivanandappa H Doddagoudar. In this video lecture, I am going to take a BSc 5th semester Mathematics paper 3, Statics and Laplace Transforms. Okay, in that paper itself, I am going to deal with that Laplace transforms. In that topic itself, I am going to take that a unit impulse function or Dirac delta function it is. Now, here Dirac delta, he is a famous English physicist, Paul Dirac. Paul Dirac it is, his name is Paul Dirac. He won a Nobel Prize at the age of 31, for his work on that quantum theory it is. Now, here he got this unit impulse function or Dirac delta function it is. Now, the definition of Dirac delta function it is the unit impulse function or the Dirac delta function delta of t minus a is defined as follows. Delta of t minus a is equal to limit of delta epsilon of t minus a, epsilon tends to 0, a greater than or equal to 0, where delta epsilon t minus a is equal to what it is 1 upon epsilon if a less than or equal to t less than or equal to a plus epsilon, 0 otherwise. Now, we can take the Laplace transform of a unit impulse function or Dirac delta function. That means, we have to calculate the Laplace transform of that unit impulse function or Dirac delta function. Prove that Laplace transform of delta of t minus a is equal to e to the power minus s, or they may ask find the Laplace transform of Dirac delta function. By definition of that Dirac delta function, delta of t minus a they are going to define like this. Now, we have to calculate the first L of delta epsilon t minus a, that is equal to 0 to infinity e raised to minus s t delta epsilon t minus a dt it is. Now, using the definition it is splitted 0 to a to plus epsilon, a plus epsilon to infinity. Now, here a to a plus epsilon it is 1 upon epsilon, 0 otherwise, that means before that a and after that a, value of that delta epsilon t minus a is 0. Now, that is why first term is 0 and the last term is 0, only thing remains a to a plus epsilon e raised to minus t del of epsilon t minus a it is. Now, here that is what it is, delta of epsilon t minus a is 1 upon epsilon. Now, we can take that we can integrate this one, it is e raised to minus s t integration e raised to minus t divided by minus s it is. Now, minus 1 upon epsilon s we can take it outside and put the limits of integration, that is upper limit minus the lower limit. We are getting e to the power minus a s into 1 minus e to the power minus epsilon s divided by epsilon s it is. Now, for this one we can apply the limit, therefore, here because limit of L of delta of t minus a we need, for that one we have to take the limit of del of epsilon of t minus a. That is why in this step we have taken a limit for that one it is. Therefore, limit of L of, that means Laplace transform of del of epsilon into t minus a, that is limit of epsilon tends to 0 e to the power minus s into 1 minus epsilon e raised to s divided by epsilon e raised to s, that is equal to e to the power minus s as it is. Then we know the standard limit, limit of 1 minus e to the power x divided by x as x tends to 0 is 1 here, that is why this limit becomes 1. Therefore, the answer is e raised to minus as. Now, the examples on that one it is. Now, these are the examples, try to solve these examples. Here I will do one example here. Example number 1, find Laplace transformation of 2 times del of t minus 1 plus 3 times del of t minus 2 plus 4 times del of t plus 3. We have Laplace transformation of t minus a, it should be, sorry, make it as a there it is, t minus a is e to the power minus as here. Now, that is why here 2 as it is in the first term, del of t minus 1 is e raised to minus s plus 3 times del of t minus 2 is e raised to minus 2s plus 4 times del of e raised to 3s it is. Now we will take that example number 2 here. Find L of cos 3t, cos hyperbolic 3t del of t minus 2 it is. We know that cos hyperbolic 3t is e raised to 3t plus e raised to 3 minus 3t divided by 2 it is. That is 1 by 2, we can take it outside, we can write it as e raised to power 3t del of t minus 2 plus L of e raised to minus 3t del of t minus 2 it is. Now 1 by 2 as it is, L of that first bracket plus L of that second bracket, that is we know that here delta of t minus 2 Laplace transform is e raised to minus 2s it is. Because of that e raised to 3t, replace s by what it is, s minus 3 it is. That is why we are getting Laplace transformation of e raised to 3t into del of t minus 2 is e raised to minus 2 into s minus 3 plus second term also is similar, e raised to minus 2, but in place of s we have to substitute s plus 3 there it is. Now that is why it is e raised to minus 2 times s plus 3 it is. Now here we can take that e raised to minus 2s common, divided by 2 as it is e raised to 6 plus e raised to minus 6, that is equal to e raised to minus 2s into cos hyperbolic 6 it is. Now these are the some multiple choice questions. Try to solve these examples yourself. Now these are the some references here, and thank you very much.